Okay, when you think star, what pops into your head? I bet it's something like a giant, raging ball of fire, right? Just this untouchable inferno. But what if I told you that some stars out there are so incredibly cold, you wouldn't get burned? You'd actually get frostbite.
Yeah, let's just dive right into that because this whole contradiction is honestly one of the coolest, and I mean that literally, things in the cosmos. You've got the stereotype, the scorching inferno we all picture, and then you have this completely bizarre reality that just blows that whole idea out of the water. So, to really wrap our heads around how a star can be freezing, we have to start with the star we all know best. I'm talking about the one that basically created our entire mental image of what a star is supposed to be. And there is our very own sun. It's what's known as a G-type star, and its surface temperature is rocking about 5,800 Kelvin. That's insanely hot. It's the perfect poster child for a classic star, right? But here's the thing. That's just one tiny page in a truly massive cosmic encyclopedia. So how do we start flipping through those other pages? Well, astronomers have this amazing tool. It's kind of like a cosmic thermometer that they use to sort through all this incredible diversity. And what it shows us is a universe just packed with stars of all different temperatures. It's called the Morgan-Keenan system. And the key thing to know is that it doesn't sort stars by size, not at all. It organizes them purely by how hot they are. Think of it like a huge spectrum with some really wild extremes at both ends. And man, this spectrum is just fascinating. You start at one end with these blazing hot blue O-type stars. We're talking temperatures over 30,000 Kelvin, just absolute monsters. Then as you slide down the scale, you pass our familiar yellow-white sun, and you keep on going, all the way down to the cool, dim M-type stars, which glow with just a faint, dull red. And it's right here, at this cool end of the spectrum, that things start to get really, really interesting. We're now entering the territory of red dwarfs, and something even colder and weirder, brown dwarfs. Now, you might be thinking these little red dwarfs are just some rare cosmic oddity, right? Nope, not even close. They are, by far, the most common type of star in the Milky Way. Get this, they make up about 75% of all stars. They are the true silent majority of the galaxy. So why are they so cool? Well, it all comes down to one thing, mass. They're total cosmic lightweights. And because they're so small, the pressure in their cores is way lower. This means their nuclear fusion is less of a raging inferno and more of a slow, steady simmer. And that lets them sip their fuel for trillions of years. Our closest stellar neighbor, Proxima Centauri, it's one of these guys, clocking in at a chilly 3,000 Kelvin. But believe it or not, we can go even colder. So what happens when an object forms that doesn't even have enough mass to get that slow simmer going? Well, you get a brown dwarf. People often call them failed stars. They start to form just like a star, but they just don't have the gravitational oomph to kickstart hydrogen fusion. So instead, they just glow faintly with leftover heat from their birth and then slowly cool off for the rest of time. And this whole cooling down process creates its own little subcategories. You have the warmer L-types, which are still pretty warm, sometimes overlapping with the coolest red dwarfs. Then you get the T-types, which are a definite step down in temperature. But the real record breakers, those are the Y-types. Here, temperatures plummet below 500 Kelvin. At this point, the word hot doesn't even apply anymore. And that brings us to the main event, the undisputed champion of cold, the single coldest star-like object we have ever found. This is the one that completely shatters everything we thought we knew. So, after traveling all the way down this cosmic thermometer, from scorching blue giants to these dim little dwarfs, what's the absolute rock-bottom temperature we've ever found for one of these things? All right, here it is. The number is 285 Kelvin. To put that in perspective, that's about minus 23 degrees Celsius, or minus 9 Fahrenheit. I mean, come on, that is not a star's temperature. That's a Tuesday in February. Let me say that again. This star is literally colder than a winter day in Antarctica. It is just genuinely, shockingly cold. So what is this thing? Its official name is WISE 0855-0714. It's our record holder for the coldest brown dwarf. And get this, it's actually pretty close, only about 7.6 light years away. And what's even crazier is that its atmosphere has water vapor and methane in it, making it sound a lot more like Jupiter than any star you could possibly picture.
Okay, so this brings us full circle, right back to that wild idea from the beginning. With temperatures this low, could you actually reach out and touch it without getting incinerated? Let's do a quick reality check on that.
Well, look, as fun as it is to imagine, this whole touchability thing is really just a playful thought experiment. It's a fantastic way to help us grasp just how mind-blowingly cold this object is compared to something like our sun.
Because here's the deal. While the temperature might be survivable for a second, everything else is absolutely not. The gravity would crush you instantly. It's dozens of times stronger than Earth's. And the atmosphere? It's just a thick, crushing, toxic soup. So yeah, you wouldn't burn, but you definitely wouldn't be walking away either.
So why is this so important? Why does it matter that we find these chilly little worlds? Because they're basically a missing link in our understanding of the cosmos. They fill this weird, mysterious gap between giant planets like Jupiter and the very smallest stars. They give scientists a perfect natural laboratory to see how atmospheres behave under some truly bizarre and extreme conditions.
When you think about it, this really shows two totally different ways to be a star in the universe. You've got your hot, massive stars, the rock stars, you could say. They burn bright, live fast, and die young in these spectacular explosions. And then you have these quiet, cool, dim dwarfs. They just hang around, sip their fuel, and will keep on faintly glowing for trillions of years, long, long after everything else is burned out.
I think the biggest takeaway from all of this is that our cozy little stereotype of what a star is, well, it's just a tiny, tiny piece of an unbelievably strange and diverse cosmos. It turns out some of the most incredible wonders out there aren't in the blazing fire and light. They're hidden away, waiting in the cold and the dark.
And that really leaves us with one last kind of mind-bending question, doesn't it? If we were this wrong about something as basic as what a star is, what else are we wrong about? Just think about what other incredible cosmic secrets are still out there, just waiting for us in the dark.